Today we are going to deal with the product rule. So the basic product rule or the UV rule is of this form: duv by dx equal to uv dash plus vu dash. Okay, so these are some of the examples not needed, and yeah, just see this formula. Uh, okay, so we are using this formula to find out the uh, to deal with the non-homogeneous questions. Okay, till this time we were dealing with questions where RHS not e is equal to 0, but now just see this example: the RHS is not equal to 0, so this is a non-homogeneous type of question. So uh, for dealing with the non-homogeneous questions, the complementary function is not enough. We need another thing, that's the PI, in addition to the complementary function, to find out the solution. So we are finding the CF and PI separately, and as I said, the formula to find the PI is RHS by function of D, and the function of D is nothing but the D square plus 4, which is this part of the question. Okay, and the RHS is just the RHS side itself. It's cos 3x. Yeah. Uh, Rather than doing this particular example, we can just go directly solve some problems. That's better, I guess. So, going to the first question, we have solved d square plus 4y equal to e to the power 4x plus cos 3x. So, as this is a non-homogeneous question, we have to find the CF and PI and substitute no by using the YS solution finding procedure. So to find the CF, we are taking the LHS side. See, d square plus 4 equal to y. We were dealing with the auxiliary equation. Yeah, the same thing. We are doing it now. So to find the CF, we are just equating d square plus 4 equal to 0, and yeah, we got a complex conjugate solution, and the final CF value comparing with the complementary function is uh, e to the power something x c1 cos 2x plus c2 sin 2x. And to find the PI, we are using the same RHS by function of t formula, and the f of t, as I said, was the auxiliary equation side of the LHS, and we are separating this term into two parts for to make it simpler and easier to solve. So and yeah, and this part we will call as yp1, and this part we will call as yp2. All this is done to make the problem look much simpler, or you can just write everything in one line and go on finding the answer. Here they did it as two sub points or two parts. They separated into two parts to make it much simpler. Yeah, then we found out the yp1 value, yp, right? It's nothing but yp is nothing but adding yp1 and yp2. So the final value is e4x by 20 plus cos 3x by minus s. And now we are combining both CF and PI, see, to find the final solution. Just finding CF and PI separately doesn't solve the job, right? We have to combine them to find the final answer. So this is the CF part and this is the PI. We are just adding it to find the final answer. Yeah, I think if you have noticed the 16 and um, minus 90 here, right? Yeah, this 16 and minus 9. Do you wonder how it came? The d value is 4 here and the d value is 3 here. Actually, they are taking the d value as whatever the constant value which is with the x. See, in the numerator, the value which is with x is 4 in the yp1 and 3 in the yp2. So d values the same variable, no, the constant with the variable that is there in the numerator. So that's all for the first question, and below that you will get a set of trigonometric formulas to solve the further questions.